All right, now let's deal with some examples. So I've seen this many times on Facebook. I don't know if you have or not, but people will kind of post this on their wall and say, if you're a genius, you'll be able to get the correct answer. So what number did you get? Most people, when I read the comments, get 0. And the reason they're getting 0 is because they're reading it left to right. And the last thing you do is multiply by 0 and you get 0. But unfortunately, the answer is 17. Now, why is it 17? Now maybe, and hopefully you actually did get 17. So what I will do is order of operations, which you've probably heard all the way in grade 6, is BEDMAS. So brackets, exponents, division and multiplication, and addition and subtraction. So what I'll do is I'll put brackets around it that actually shows kind of an easier way of solving it. So the first thing you can see is going inside brackets is I should 3 divided by 1 and compute 2 times 0. Then I see another set of brackets, which means I have to go 3 times 4 to give me 12. And then adding and subtracting from left to right, I get 17. So you can see here it's a little easier with brackets to solve these problems. Well, logic has the same kind of precedence. What we do is first are nots, second are ands, and third are ors. Meaning, if we look at this statement, A and B or not C, again, without brackets, it might be a little confusing. So knowing the precedence and which one comes first, second, and third, we actually could write it like this: A and B or not C. Now, you'll first see this kind of double arrow. We are going to talk about it a little later in lesson 2, but for now, just think of that arrow means it's equivalent. It's the exact same thing. So now let's discuss some properties of logic. So first is cumulativity. Cumulativity states that A and B and A are equivalent statements, as well as A or B, and B or A are also equivalent. Next is associativity. Associativity states that if you have 3 statements all joined by the same logic operator, that the order of brackets actually doesn't make any difference. So A and B and C inside brackets is equivalent to A and B inside brackets and C, as well as A or B or C is equivalent to A or B or C. And the last one is distributivity. Now you've seen this. This actually should remind you of what happens if you multiply something into brackets. And you've probably heard the distributive property of addition and multiplication. Well, logic also holds it. So first we will see that A and B or C is equivalent to A and B or A and C, as well as A or B and C is equivalent to A or B and A or C. Alright, and we'll learn about one last one, is what's called idempotence. And idempotence just simply states that A and A is equivalent to A, as well as A or A is equivalent to A. Alright, now I will show the proof of a distributivity rule, namely the one that states that A and B or C is equivalent to A and B, or A and C. Now, if you remember from lesson 1, to prove this, we have to show that the left side truth table values are equivalent and equal to the right side's truth table values. So first off, we're going to start with all the truth values A, B, and C can take on. You'll notice this one's a little longer, as we now have a third clause. Starting at the left side, we can see that the truth table values of B or C. So if you remember, if B or C are true, then the B or C becomes true. Then we take that and we say when is B or C and A true, and we end up with the left side's truth table values. Now going to the right side, we can do the A and B part, as well as the A and C part. And lastly, you can actually see how when is A and B or A and C true. And what you'll notice is both the left sides and the right side's truth tables are exactly the same. Alright, I don't know if you've ever been to Eastside Mario's, but at the top of the menu it says if you order, all Liberty pastas and Mario specialities are served with complimentary soup or salad and freshly baked garlic home loaf. Now let's talk about this. Let's see, I used to work at Eastside Mario's, and this kind of always bugged me after I learned logic, is let's let A be the statement you receive soup, B be the statement that you receive salad, and C be the statement that you receive garlic home loaf. Well, if I just take what they have, notice there's no commas or nothing, and I just simply take it into the statement, we would read it as A or B and C. Now, just like that Facebook post earlier, this can actually be read differently than I think how it's intended. A or B and C. Now, of course, the intended version is actually A or B and C, meaning after working there for 5 years, or if you've ever been there, what they really mean is they mean that you either get soup or salad, and no matter which one you choose, you get garlic home loaf. However, you can see that the intended version and the version it actually is are not equivalent at all. So what we can do is, knowing what the distributive property looks like and how we've seen it before, is we actually could rewrite this as A and C or B and C. And now what we could do is, turning it back into English, we could really say served with soup and bread or salad and bread. And one last thing, this sentence here, served with soup and bread or salad and bread, talks about the difference between ors in language and ors in logic. Because if this was a logical or, a customer rightfully could order both soup and bread as well as salad and bread. However, this or here implies an exclusive or. An exclusive or will be discussed in the assignment, and you will have to develop a truth table on how to deal with an exclusive or.